Greetings, friend. Yoshi Baroshi made the best classic Sudoku for practicing Snyder notation. I'll show you how to solve this puzzle along with the main strategy that you can see easier by using Snyder notation. Click below if you want to give this puzzle a go. And with that, it's solving time. Okay, if you're not that familiar with Snyder notation, I'll show you how to find that. So you have this 2 right here. And there's no possibilities in column 8 in the block for a 2 because you have a 2 in block 3. And if you look right here, you'll see that a 2 can't be in this spot either. So in column 8, the 2's are limited to 2 spots. And since they're only limited to 2 spots and they're contained within block 9, this is called a claiming pair. But I marked in these corners 2 spots that the 2's can be. And since we know the 2's are here, they can't be anywhere else in the block. And we already know they can't be in the column. So this is called Snyder notation. Anytime in a 3x3 block, you have 2 possibilities for can it, mark it. In case you solve one of these cells, you can solve the other one right away. And this is special because it's a claiming pair, which means you can eliminate a 2 from here and here as well, even though you already had these 2's. I cover claiming pairs in my latest rewards puzzle pack. Click on the pinned comment link if you like to solve claiming pairs. All right, let's look at the 3's. We have a 3 here, we have a 3 here, and we have the 3 cutting across row 7. That means the 3's are limited to 2 spots in block 8. So I'm going to make a Snyder mark for there. And I'll just call them the Snyder and wherever the candidate is to make this a little quicker. Okay, with the 4's, you have this 4 cutting across row 5, this 4 coming up. So there's 2 possibilities for 4 here in block 5. And I'll color this because there's 2 possibilities here and they're in the same column. These 4's are also called locked candidates or pointing pairs. And what it means is a 4, since it has to be in column 5 in block 5, a 4 cannot be anywhere else along column 5 anymore. They point up. You can't allow a 4 there. We already have a 4 right there, so we know that. So it can't be 4 in any of these 2 spots. And so what it does is it restricts the 4's to these 2 spots now in block 2. And so we can make that mark for the 4's. And then let's look at the 5's. You got these 2 possibilities for a 5 right here. The only place we can do Snyder 5's is in block 9. And then let's look at the 7's. Okay, what's nice here, you notice how that 4 came across row 5 here. Well, the 7 cuts across row 5 as well, and the 4 and 7 are in the same column. And so what you'll see is if you did your marking, you'd go, okay, I got a 4 and a 7 right there. Whenever the Snyder marks are in the same 2 cells, then what you know is you have a restriction where those 2 cells can only be those 2 candidates. And this is called a hidden pair. You have found a hidden pair. And so we can mark the cells with those 2 candidates because the 4 and 7 have to be in 2 places in block 5, but they're the same 2 places. No other candidate can be in those 2 cells. Once I mark a hidden pair like this, I will remove the Snyder marks so that I can have a little bit less clutter, and I know that they're going to be acting as a pointing pair or a claiming pair as well. So there's just like the 4's. Now you got the 7 here, you got the 7 as part of this hidden pair, which is a pointing pair, and it restricts the 7's to these 2 spots. So we have another 4-7 hidden pair. And so we're going to be able to mark that. And so now we can create some more Snyder marks here in block 5 because the 5 cuts across. They're only limited to these 2 spots right here. And so we have the 5's as another pointing pair. 5 can't be here. You have the 5 cutting across. You have the 4-7 hidden pair. Now the 5's are limited to 2 spots in block 2. This next trick with the Snyder marks is very fun. You got to see this. All right, we're going to start with this 8 right here, cutting across row 8. Leaves only 2 possibilities for the 8 in block 7. And since they're in the same column, they're a pointing pair. Now, this pointing pair comes all the way up, column 1, and it leaves 2 possibilities for an 8 in block 1. And so now this is another pointing pair with the 8's. And so what can we do with that? There's actually plenty that we can do with this, okay? First, we can actually notice there's a 2 in rows 1 and 2, so we can solve this cell for a 2. But this 8 acts as a pointing pair of 8s, and since we have a hidden pair here, we can solve this cell for an 8. And what we just did is called displacing the Snyder. We displaced the Snyder 5. Once we displace, we can solve the other cell immediately for a 5. We're not done with the 8s. Now this 8 cuts all the way down column 5. This 8 cuts across, so we can solve this cell now for an 8, which displaces this Snyder 8, and we can solve for an 8 right there. And then with these two 8s and this 8, we can solve for an 8 right here, displacing that Snyder 5. Okay, and then with these two 5s and these two 5s, we can solve for 5 over here in block 4. Got all kinds of solving going on because we started with this pointing pair of 8s. And we're not done with the 8s yet, because now you have these two 8s and this 8. We can solve for an 8 right here, displacing that Snyder 8, solving this, an 8 for right here. And with these two 8s and these two 8s, we can solve our last 8 right there. Yoshi Baroshi names his puzzles either after the way it looks, the idea behind the inspiration, or something extravagant that will make the solver curious. Do you like the name of this Yoshi puzzle? Do you think it's appropriate? Let me know in the comments. After we did all that solving, now we have just two possibilities here in block 5, a 2 and a 6. I see a 2 right there, so we can solve this for 2 and solve that for 6. We're about to embark on another wave of Snyder solving here. So we're not done with the Snyder notation marks just yet, but we can do some cleanup. You'll notice we have the 4, 7 here. We have these 6 candidates filled out. The only thing missing in block 1 is this 1. So I can put 2 marks for 1 here, for Snyder 1s. And then if you come down, we have a full house here in column 4. So the only candidate missing is a 2 right there. And with this 4, 7, filling those two spots, it's like we have a full house here as well. So we can mark a 6 right there. Okay, after doing all of that, we're going to start our next round of Snyder marks. So you have this 7 cutting across here. You have this 7 coming down. We have 2 possibilities for 7, and so we'll mark that. They're also a pointing pair, and so 7s can't be here anymore. But since there's 3 possibilities for 7 here, I'm not going to mark the 7s. I don't advise that in classic Sudoku because you get so used to displacing Snyder marks and marking right away. Whenever you have 3, you might accidentally mark when there's really not a solve you can do. So try to stick to just the 2 and the pairs there. All right, after doing the 7s with the Snyder mark, then the next thing we're going to do is look at the 3s. All right, let's look in block 1. You have a 3 coming up. Column 3. You got this 3 cutting across, 2 possibilities for a 3 in block 1. And that is Snyder marks, also a pointing pair. Now the 3s can't be in these spots. You got this 3 coming up, and you have this 3 cutting across row 6. So we can actually solve for 3 now in block 4. But not only that, what you'll notice is with these two 3s, we can solve for 3 here, which is going to allow us to solve for a 1 right there. And now with these two 1s, the only place left for a 1 in block 7 is right there, which displaces that Snyder 7 that we marked. Awesome. And then with these two 7s, we can put a 7 right there, which is going to allow us to disambiguate our naked pair 4 and 7. Great. And now you see here with these two 7s, you can put a 1 and a 7 right there, which allows us to have basically a hidden pair. And so we know that the only thing left has got to be a 3. So we can mark this for a 3 and remove that Snyder mark. This is a little bit of cleanup that we're going to do. The other thing you may notice too is now we have this 3 and this 3. So 1, 7 doesn't allow a 3 to be right there. So we can solve for 3 right there. And then the last 2 digits we have up here are a 6 and a 9. But we can't solve the 6 and 9 just yet. But we're going to get there. What we can do is use these 6s as a pointing pair. So it's like a Snyder mark. It's a pointing pair. You got this 6 coming up. We can solve for 6 right there. And now we can use these 9s also as a pointing pair. No, a 9 can't be there. And with these two 9s, we can solve for 9 right here. And then knowing that you have a 2 right here means that the only place for a 2 in block 4 is right there, which allows us to solve for a 4. And we're going to disambiguate the 7, 4 right there. With these two 6s, we we can make a Snyder mark of 6s in row 4. And now we can come down and finish block 7. Whenever you see 8 candidates, it's a full house. You know there's only one missing. Whatever that missing is, you can solve it. So that's got to be your 9, and this would have to be your 4. And now what you'll see here is we have 2 5s marked right there. But we got these 2 4s in rows 7 and 9. So 4 cannot be there. And because of this 4, 4 cannot be here. This has to be a 4 displacing that Snyder 5, which displaces our Snyder 2 mark. Awesome. All right. And after doing all that, you can see there's only one possibility left. We have a marking there. It's a 3. So we can clean up the Snyder mark and solve that for a 3. Let's look at these 4s. You have 2 4s here. And since we have a 1 7, they compare there. The 4 can only be in this spot. And now I want to show you a cool, neat, naked triple trick. All right, you see you have 3 candidates missing in row 1, 5, 6, and a 9. Well, I have the 5 and the 9 right here in column 8, and I have the 5 repeated in column 1. That means we can solve all 3 cells. This 5, 9 means there's only one possibility left, a 6. And wherever the 5 can't be, that's got to be in that cell, which leaves a 9 right here. That's my neat, naked triple trick. You have 2 of a candidate looking into one of the possibilities, and you have another one repeated. You can solve all 3. All right, that leaves us for a 6 right here, and I don't see a 9 yet in block 3, so that's got to be a 9. Awesome. And now focusing up here, we got this 2 coming down. It can be a 2 or 6 here in row 4, and since the 2 can't be in this cell, this has got to be your 2 displacing that Snyder 6. And now with these 2 6s and this 6, we can solve for 6 right here. And now I want to show you another cool trick. I call this my right angle trick. You notice there's only 2 possibilities right here in block 6. That's got to be a 1 or a 7, right? And then if you look down the column, the 1 and 7 are limited the same naked pair in column 9. Well, if we can find one of these candidates outside, it'll solve all 3 of these. So I look here, go 1 7 there, 1 7 there. I need a 1 or a 7. Boom! I see a 7 right there. I know I can solve this for a 1, that for a 7, and that for a 1. I cover how to do this type of solving in my double cell combo tutorial. Let's finish up here. This one allows us to disambiguate the 7 and the 1 right there, which now with these 2 7s means this has to be a 7. We don't have a 3 or 9 yet, so I got my 3 here. So this is a 3. That's a 9, which means this has to be your 9. The last digit is a 1. Practice some more Snyder notation with this video. Thank you so much, Yoshi Baroshi, for being my Friday featured setter. I really appreciated this, and thank you so much for watching.